Hi everyone, my name is Ree Benting Flores. Good day, and once again, welcome to my YouTube channel. So for today's video, we will be reporting a review topic which is all about the IBP or the integration by ports. But I have already a video, or in my previous video, I already presented this topic, and I'll be including the link down in the description box. But before we proceed to our review topic, let us review these formulas of integrals first. First is we have the integral of x raised to the power of n dx is equal to x raised to the power of n plus 1 all over n plus 1 plus c, where n is not equal to -1. On the left side, or on the other side, we have this integral of 1 minus 1 over x dx is equal to the ln absolute value of x plus c. So the second column, we have the integral of e raised to the power of x dx is equal to a raised to the power of x plus c. And the last one, we have the integral of e raised to x dx is equal to a raised to x all over n ln of a plus c. So this is another set. It is including the trigonometric functions. So we have this first column, we have the integration of sine x dx, which is equal to negative cosine x plus c. Integral of cosine x dx, which is equal to the sine x plus c. Second column, we have the secant square dx plus dx is equal to the tangent x plus c. And then the integral integral of the cosecant square dx, which is equal to the negative cotangent x plus c. The last column, we have the integral of secant x tangent x dx is equal to the secant x plus c, and the integral of the cosecant x cotangent x dx, which is equal to the negative cosecant x plus c. So this is the last group. For today's video, we have the integral of the sine h x dx, which is equal to the cosine of h x plus c, and then the integral of cosine h x dx is equal to sine h x plus c. Second column, we have this tangent x dx, which is equal to the ln, the absolute value of secant x plus c. The integral of cotangent x dx, which is equal to the ln, the absolute value of sine x plus c. And the last column, we have the integral of 1 over the x squared plus e squared dx is equal to 1 over a tangent raised to -1, or the arctan, rather, x over a plus c, and then the integral of 1 over the square root of a squared minus x squared dx is the arc sine, or sine negative raised to -1 x over a plus c. So this is now our main topic for today, a review topic, which is the integration by parts. And in this section, we will be learning about how to integrate complex function by parts. Integration by parts, in every differentiation rule, it has a corresponding integration rule. For instance, we have the substitution rule for integration corresponds to the chain rule for differentiation. We also have, as you observe, the difference between the power rule of differentiation and integration. In integration, we are adding 1, but in differentiation, we are subtracting 1 to the power of the given. So in integration by parts, we also have the rule that corresponds to the product rule for differentiation. It is called the rule for integration by parts. So the counterpart of integration by parts to the differentiation is the product rule. So in product rule, it states that if f and g are differentiable functions, then we have the derivative of f of x g of x is equal to the derivative of f of x g prime of x plus g of x f prime of x. So this is the counterpart of that product rule to integration, which is the integration by parts with these notations. So we have this integral of f of x g prime of x plus g of x f prime of x dx is equal to the f of x g of x, or we can also use this notation of the integral of f of x g prime of x dx plus the g prime of the integral of g of x prime f prime of x dx is equal to the f of x g of x. So we have the same goal, but in differentiation we are starting here. We are starting here, and this will be serves as our answer. However, in the integration by parts, in integration, we are starting here, and this will serve as our answer. So proceed. We have this two formula to consider in integration by parts, solving integration functions using integration by parts. We can arrange this equation into the integration of the f of x g prime of x dx is equal to the f of x g of x minus the integral of g of x f prime of x dx. This formula is called formula for the integration by parts. It's perhaps easier to remember in the following notations. So we have also another formula, as we let use U substitution, as we let U be equal to f of x, and the v is equal to the g of x. Then the differentials are the du is equal to the f prime of x dx, and the dv is equal to the g prime of x dx. So we have this second formula from that. We have this formula of substitution rule. The integral of u dv is equal to uv minus the integral of v du. So this is our first example. Find the integral of find the integral of x sine x dx. Suppose we choose f of x be equal to x, and then the g prime of x be equal to sine of x. Then the f prime of x be equal to 1 is it because the derivative of x is 1, and the integral or integration of sine of x is negative cosine of x. For as the value of g of x. For g, we can choose any antiderivative of g prime of x. So using the formula 1, we have this. The integral of x sine x dx is equal to the f of x g of x minus the integral of g of x f prime of x dx. We just substitute the value of f of x, g of x, g prime of x, and f prime of x. So we all know that we denote f of x be equal to x and g of x be equal to the negative cosine x minus the integral of negative cosine x 1 dx as the value of our du. So we have this, as we substitute or combine these terms, we came up with a negative x cosine x plus, it becomes addition because it is both negative, so we have x, or negative times negative, so we have positive, the integral of cosine x dx, and then we integrate this, and then we came up with sine x, and then combine, so we came up with negative x cosine x plus sine x plus c. So it is wise to check the answer by differentiating it. If we do so, we get x sine x as expected. Is it because, as what I have said earlier, that the process of differentiation starts here and to this form as the answer. However, in integration, we starts here and ends with this form as the answer. So next is, as we try the U-substitution or substitution rule. We let u be equal to x, the same as f of x, and the dv be equal to sine x dx as the g prime of x, and then the du we have 1 dx or dx, and our v be equal to the negative cosine of x. We just plug these values, so we came up with the integral of x sine x dx is equal to the integral of x as our u, sine x dx as our dv, is equal to x as our u, negative cosine x as our v, minus the integral of negative cosine x as our v again, and then the 1 dx or dx is as the value of our du. We just combine this, so we came up with negative x cosine x, and then we all know x plus x times x, and negative times negative, it becomes positive, and we copy the integral cosine x dx. We integrate this, and we came up with sine x combines the negative x cosine x plus sine x plus c, the same answer we get from the first formula. This is the example number 2, and it is your task to try. Evaluate the integral ln x dx. Here, we don't have much choice for u and dv, so let u be equal to ln x and the dv be equal to dx. Then our du is expected to be 1 over x dx, and our v is equal to x. That will be all. Thank you and God bless.